Assalamualaikum and hello to my panel, Encik Muhammad Afiq Amiruddin and Encik Ahmad Nizam. This is my video slide presentation for PSM1 on assessment of surface morphology of laser engraved stainless steel. To begin the presentation, let me introduce myself first. My name is Muhammad Haziq Zafrin bin Alwi and I'm in my third year of studies toward Bachelor of Mechanical Engineering Technology, Maintenance Technology with Honours. For PSM subject is Professor Madya IR Dr. Muhammad Hazli bin Abu Bakar. Introduction Chapter 1. What is laser engraving? According to the background, laser engraving is a method that vaporizes material into fume to engrave permanent deep marking. The laser beam acts as a chisel, incising marks by removing layers from the surface of the material. Then the laser hits localized areas with massive level of energy to generate the high heat required for the vaporization. Problem statement of this research is effect of using low diode laser engraving to the surface roughness and engraved depth. Second is quality of surface morphology on stainless steel. And lastly, altering surface from non-pattern to pattern. Stainless steel material are a group of ferrous or iron-based alloys that have a high resistance to rust and corrosion, a factor that contributes to its name and its popularity. This versatile material is durable and light and can even vary in color. The research objective of this experiment is to develop a 2D design using a master oscillator power amplifier or MOPA fiber laser on stainless steel. Second is to evaluate the effect of the process parameters on the surface of the stainless steel. And lastly, to analyze the surface roughness and microstructures of stainless steel when undergo laser engraving. Next is the scope of research. The scope of this research is to create a design utilizing engraving on a metal workpiece. The next step is to assess the impact of laser engraving parameters on stainless steel pattern quality such as speed, frequency and power of the laser engraved equipment used during the procedure. Finally, a study of the impact of laser engraving on structural and microstructural alteration in stainless steel. Next is Chapter 2, which is Literature Review of Laser Engraving. The term for word laser is light amplification by stimulated emission of radiation. A laser is a process that causes atom or molecule to emit light at specific wavelength, which is then amplified to produce a very tiny beam of radiation. The emission covers a very narrow wavelength range of visible, infrared and ultraviolet wavelength. As technology evolved, lasers were able to mark or engrave materials, allowing them to make barcode, serial number, 2D codes, UDI codes, labels, pattern, and many more. Laser engraving, also known as a laser etching, is a process that includes using a laser beam to change the surface of an object. Next chapter is methodology. Stainless steel is commonly used for medical equipment, car parts or automotive equipment, where parts can be engraved with barcodes, serial number or logos for traceability. Stainless steel, jewelry and other personal items can also be engraved with text and design, whether individually or as part of a production run. Stainless steel was chosen as the material for the workpiece or specimen used to analyze the entire laser engraving process. Stainless steel has a number of advantages in the laser engraving process, including being more resistant to wear and abrasion than aluminium or other materials. The table below shows mechanical properties of a stainless steel. Okay, next is type of machine used during experiment, which is the master oscillator power amplifier or also known as MOPA. The MOPA machine can generate a pulse frequency with a broader fiber range than 1 till 4000 kHz. It can be used to supply a power source for the laser. This enables MOPA laser to provide distinct engraving results in diverse polymers and metal materials when compared to other fiber engraved laser technology. Furthermore, laser MOPA can engrave several colors on stainless steel, titanium and aluminium, as well as produce a darker color effect and a better gloss than a fiber laser. Then lastly is the microstructure of the specimen. A digital microscope, as shown in figure below, is useful for inspecting and analyzing the grain measurement of the engraved materials. The engraved region and base metal workpiece micrograph were studied in the sample. Last chapter is preliminary finding. The table below shows the expected result of laser engraving on stainless steel. The result allows for the characterization of a surface after it has been lasered at a precise setting. Furthermore, the look of the surface on the stainless steel workpiece revealed the choice of which surface was ideal for product making. Okay, that's all from me. Hope you like it. Thank you very much. Assalamualaikum.